Hello! Today, we're putting aside the usual classical mechanics routines. We've designed a hybrid system that combines the magnetic and viscous nature of ferrofluid with the buoyant force of water in a single cycle. In front of you is a U-tube with a diameter of 32 mm and a height of 50 cm, and inside this tube a liquid piston moves as if it were a living heart. This system doesn't operate alone. The entire setup works inside a water tank. We place two flexible expansion membranes, each connected to the ends of the U-tube with air hoses. You can think of these as the lungs of the system. These are the critical connections that allow the system to breathe. Now comes the critical moment. When the ferrofluid flows into one arm of the tube, a true liquid piston effect is created here. This movement compresses the air inside and pushes it toward the membrane below. As a result, the membrane inflates. The increase in volume displaces the water. The pressure reaches its peak and the laws of physics come into play. And this is where Archimedes comes into play. The inflated membrane displaces more volume than the surrounding water. This gives it a remarkably powerful upward buoyant force. A new mechanical force is consequently born. The membrane is no longer just a balloon. It's a mechanical actuator. The power of the liquid is about to be converted into mechanical motion. The membrane that reaches the surface doesn't just sit idle. Through a pulley system, it pulls the two attached to the bottom of the U-tube. This pulling force disrupts the balance of the scale supporting the system. The transfer of energy begins. Potential energy redirects the system. The cycle is about to be completed. As the scale shifts direction, the ferrofluid now flows to the opposite arm. This movement creates a vacuum effect in the first membrane. It initiates the transfer of air to the other membrane. To put it in another way, the system automatically triggers entirely by itself. The cycle doesn't stop. Each movement prepares the next one. This ongoing and difficult struggle with friction losses, air leaks, and complex pressure balances will provide us with a wealth of invaluable knowledge about the intricate design of sustainable mechanical systems. So, how many cycles will this liquid piston loop complete? We will find out together. Stay tuned.